So this lesson is about complex numbers. Complex numbers have to do with taking the square root of -1, and we call this the imaginary unit. So if we take the square root of -1, notice that that's going to be I. And then also that I squared equals -1. Now we're going to take some roots and work with the square root of -1 first, and then we'll deal with the I squared equals -1. And if you think about it, if I took both sides and squared the I and squared the square root of -1, then you get I squared equals -1, going back to some of the rules that we've learned so far in the radical chapter that we've been in. Okay, so when we're looking at the square root of -49, that is the square root of -1 times 49. So we can take the square root of -1. You can also write it as the square root of -1 times the square root of 49. These mean the same thing. So you can write it under one radical or under two radicals, whatever makes the most sense. So when I take the square root of -1, that's I, and the square root of 49 is 7, we write that as 7I. And so part of what I'll be teaching you is how to write this properly, where the I should go in your answer. On the next one, we're going to take the square root of -1 times the square root of 3. Now the square root of 3 doesn't simplify any further than it is. The only other thing we could do with that is a decimal number, and we don't want that because we want this in radical form. So my answer on this is going to be, right, the square root of -1 is I. And we write this in front of the radical. And we do this for this simple reason. We don't want the I to ever look like it is under the radical, because the whole process here is that we're taking the square root of -1 and that's the I. So we don't want it to look like the I is actually under the radical, because that would never be the case. And the next one, so we would take the square root of -1 times the square root of 100, right? And then that's going to be, the square root of 100 is 10. The square root of -1 is I. All right. Now, in the past, when we would have something like the square root of -100, we would say that's not a real number. Well, it still isn't a real number. It's an imaginary number. And apparently there's some imaginary units used in electricity, which I don't know anything about. I just know that that's the facts, that it is used in electricity. Okay. So on these, we get into a little bit more rigor, I guess you would say, because we have to simplify more than just the -1. On this first one, the square root of -32, well, we have the square root of -1, but also we're going to split the 32 into a perfect square times what else is there. If we factor 32, then we would get that it is 2 times 2 times 2 times 2 times 2, right? Which is 16 times 2. So you can see that we can take the square root of the 16. We can take the square root of -1. So that's going to be 4I times the square root of 2. So the 2 is the only part that remains under the radical. All right. So now let's go to this next example, 4 times the square root of -20. And so whatever we can bring out, we will be multiplying times 4. So we have 4 times the square root of -1. And then 20 is 4 times 5. So we could go ahead and split that up, or you can factor 20, right, as 2 times 2 times 5. So instead of the 4, we could write this as 2 squared. So you can see that we're going to have a root, because that matches my index of 2. Remember, a square root has an index of 2. So we take the square root of 2 squared, which is 2, multiply that times 4. The square root of negative 1 is I, and then the 5 stays under, right? I'm going to go ahead and go back to the 4 on this. The square root of 4 is 2 times 4, and so on. Okay, so that's simplified, and then the next one, we're going to have a negative 1 basically on the outside. So that's, I'm going to write that as negative 1. So we have negative 1 on the inside. And then 63 is 9 times 7. Now I'm just going to go ahead and do 9 because, and like on the other one at 4, because those are very common perfect squares. And in this particular lesson, it's only square roots that we're working with. We're not going to do anything beyond that because that's how we're working with imaginary numbers, is we're taking the square root of a negative. Now, to simplify this, right, I can take the square root of 9 and the square root of negative 1. So that's going to be 3i. I'm multiplying that times negative 1. And then I have times the square root of 7. So this would be negative 3i radical 7. And so you maybe didn't have to write that other step that I wrote, but mainly I want you to be able to get to the correct answer here. Okay, so now we're multiplying or dividing. You just have to be kind of careful here and make sure that you you take the square root of the negative ones and bring those out so that you don't lose that somehow as you're working on these. And that can happen sometimes, because if you look at this first one, if I just multiplied those, then I actually would end up with the wrong answer, because that would make a positive, and then I don't take out the square root of negative 1 or work with that at all, and it ends up having the wrong sign on the answer if you do it that way. So we are going to make sure that we take the square root of the negative 1 out and then go from there. So on both of these, right, we have negative 1 times 11, negative 1 times 3. So we're going to have I radical 11 times I radical 3, right? We take the square root of negative 1 and that comes out. And then we multiply. So when we multiply, we get I squared times the square root of 33. Well, remember back at the very beginning, we had this thing that said I squared equals negative 1. So this means every single time we have an I squared, we're going to replace it with negative 1. So we have negative 1 times the square root of 33. And that's just negative square root of 33. Now, I know I went through a lot of steps there, but I just wanted to explain that as thoroughly as possible. Okay, next. On this, we can remove the negative 1, the square root of negative 1. So we're going to have I times the square root of 2 times the square root of 6. Well, that's I times the square root of 12. And then we can factor 12 as 4 times 3. And because these are just simple numbers, I'm going to just show you this with perfect squares, okay? The square root of 4 is 2. That comes out. The square root of 3 stays under. All right, so this next one is division, and we actually could divide negative 80 by negative 10 and start there. But remember what I told you about making sure that you don't mess up signs by working with your eyes, right? Take the square root of the negative out. So let's first do that, right? Both of these will have an I. So I have I times the square root of 80. Over I times the square root of 10. Well, I divided by I is just 1, right? So that does actually eliminate the i's, but I would rather see you do it in this way to be on the safe side. So on the next step, I'm going to say, okay, that's equal to 1. And I can divide the 10 into the 80 because they're both under the radical, right? So 10 goes into 80 8 times, which is the square root of 8. And then we can simplify one more step because 8 is 4 times 2. The square root of the 4 comes out, and then the 2 stays under the radical, and we have that simplified completely there. All right, so I just like to throw this in about complex numbers that in the past we've talked a lot about real numbers, right? And so whenever we talk about real numbers, then we have all these subsets that are equal to, or that are part of the real numbers, like rational numbers, irrational numbers, and so on. Well, then we jump into complex numbers. And notice in the definition up here, it says that it can be written in the form a plus bi, where a and b are real numbers, okay? But that also gives us that imaginary part where we have the bi. So this is really just about sets of numbers. This chart comes from your textbook. I don't want you to get real hung up on this. I just like to show it as, okay, look at all these sets of numbers that we have here. Okay, so on this part, we are going to add or subtract, add and subtract, I guess you could say. And these are pretty quick questions, so I think we can finish these on this video, and then I'll start on a second video for multiplication. Basically, on this, we are going to combine like terms, okay? And don't forget that we've got to pay attention to the fact that, like on this first one, we have subtraction. So if I remove my parentheses, I would say 2 minus 4i, and then that's minus 2 plus I. Well, I can add the imaginary numbers together and the real numbers together. In this case, I'm going to have 2 minus 2, so that's a 0. And then negative 3i plus 1i would be a negative 3i. And I'm going to leave the 0 because it's telling me write it in this form. Well, if I write it in this form, I'm going to write the 0. Now, on My Math Lab, just be careful when you're watching, when you look at your instructions, that you're entering these correctly. Because on something like this, if it asks you to write it in the form a plus bi, you do have to put the 0 in there, which I know seems weird. And I just don't want you to get bogged down with that, though. Okay, so try not to do that. Or get too stressed out about it, I guess. So on this one, we can take the real numbers, 8 and negative 9, and add them. And then negative 3i plus 4i would be 1i, so that's just going to be written as I. And then we have combined, right, by adding and subtracting. All right, so I'm going to stop this video, and then we'll pick up on the next one for more complex numbers.